Hopefully my Wi-Fi doesn't go out today. Okay. There we go. All right, can everybody hear me and see?
Yep.
Yep, okay, good. All right, so, oh, let me get that, sorry. There's Sawyer. Did I get Sawyer? Yes, hi Sawyer. Okay, I've got to do that all over again. Turn this on. All right, so this lesson is on comparing linear relationships. It's really about problem solving using all the skills that you've learned about linear relationships in this unit so far. So your challenge is when we're reading through a question, see if you can figure out what it is that we'd be comparing and see if you can come up with a plan in your mind, how you might do the question before we start doing it together, okay? So these are all EQAO questions, by the way. So they're all open response EQAO questions. Some of them are multiple choice, I think, actually, sorry. So our first question is hot air balloons. A green hot air balloon, so I'll highlight it in green, is rising at a constant rate. After 2 minutes, it's at a height of 30 meters. And after 6 minutes, it's at a height of 75 meters. A blue hot air balloon is rising at twice the rate of the green one, green balloon. Determine the rate in meters per minute at which the blue balloon is rising. Show your work. Okay. So we've got a green balloon rising at a constant rate. If we knew what the rate the green balloon was rising at, and the blue one's rising at twice that rate, we could just double the green rate and we should be able to get the blue rate. So we've got a graph, so we should be able to treat these points as a table. And you can see from your grid that H is our vertical axis and T is our horizontal axis. So at 2 minutes, we're at 30 meters. And at 6 minutes, we're at 75 meters. So let's try to put those points on our grid. They were nice to us and already put the scales on both of them and labeled them. So 2 minutes is here and 30 meters. There's 1 point. And then 6 minutes and 75. So here's 70. So 75 is going to be right halfway between 70 and 80. So this is the green balloon starting here and rising to here, and we can make a right triangle out of it to get our rise and run. So we need to know the scale. So for our rise, the scale is going up by 5s. So I can go 5, 10, 15, 20, 25, 30, 35, 40, 45. So the rise here is 45 meters. And then the run, I'm going from, so each square here is worth 0.5. Or the way I like to think of it is every 2 squares is 1. So if I was counting the run out, I'd do 1. So there's 2 squares being 1, 2, 3, 4. So my run is 4 minutes. So for the green balloon, if I'm showing my work, I'd get the green balloon rate. And I would do slope is rise over run. Slope is 45 meters, rise. Over 4 minutes, run. And then I would figure that out on my calculator. So 45 divided by 4 is 11.25. And I would keep the decimal in this case because 0.25, we know that's like a quarter. It's like a perfect decimal. So I'd just keep it instead of rounding it to 11.3. So we know that the green balloon is rising at 11.25 meters every minute. And they tell us that the blue balloon is rising twice as fast at twice the rate. So to get the rate for the blue balloon, it would just be this one multiplied by 2. So 11.25 meters per minute times 2, because it's doubled. So then I just need to multiply that number by 2. So 11.25 times 2 is 22.5. So 22.5 meters per minute. And then because it's a word problem, we better make sure that they know we know the answer. So determine the rate the blue balloon is rising. So therefore, the blue balloon rises at 22.5 meters per minute. Okay. Any questions about that one? Make sense? So that one, I feel like it was fairly straightforward that we knew we were comparing the rates there. The wording was pretty straightforward to understand. The grid was really nice, given to us with all the labels and everything on it, ready to draw our rate triangle. All right, so we're going to go on to example 2. This one's a multiple choice question. So the relationship between the distance below the surface and time for 2 scuba divers is shown by the graphs below. How much faster is diver B diving than diver A? So in this question, it gives us graphs, which is good. And it asks us how much faster. So it tells us diver B is going to be faster than diver A. But it doesn't say anything about initial value. It doesn't say anything about rate of change. How do I know what they're asking me to find if I didn't? Okay, so faster, I would hope you would think faster is kind of speed and speed is kind of rate. But say you had no idea that you were supposed to find the rates for each. you could look at the answers because this one happens to be multiple choice. And as soon as you see the rates are in meters per minute, that should tell you, oh, I need rates. Okay. So then you're going to find the rate for diver A. So I'm going to show my work for diver A. And I want to make a rate triangle. So here's my diver A. So it starts at 0, 0. That's nice. I want to find a nice place here to draw my rate triangle in. Looks like it goes right up into the corner, but here I'll make my rate triangle here. And then I want to figure out my rise and my run. And then just do my work for diver A. So we have to figure out our scale for vertical. So every square is worth 4. You can also see that you start at 0 and you rise all the way up to 40. So like a quick way would be 40. And then you could also figure out your scale and go 4, 8, 12, 16, 20, 24, 28, 32, 36, 40. Okay, 40 meters. And with my run, I start at 0 and go to 5. So that's 5. Or you could do every 2 squares is 1 and count them out. 5 minutes. So we've got our rise and run. So then we're going to write our formula down. M equals rise over run. And the rise is 40 meters. And the run is 5 minutes. And then if we do 40 divided by 5, we get 8 meters per minute. So that means diver A is diving at a rate of 8 meters every minute. So every minute he dives 8 meters further below the surface. You can see the axis here says distance below the surface. So 0 represents the surface of the water. And then by 5 minutes, he's 40 meters under the water. Okay. All right, then let's look at diver B. So diver B, I want to make a rate triangle for diver B as well. So this looks like a corner here and another corner here. So we can make a rate triangle. So again, the scale here though is by tens, but we can also see we start at 0 and go up, rise up to 100. So you can either look at it that way or you can count by tens, 10, 20, all the way up to 100. And then for my run, it's counting by ones this time. So I start at 0 and end at 10, which is 10 minutes. Or you can count by ones and you'll get to 10. 7, 8, 9, 10. So again, we're set up to find the rate for diver B. And it says diver B is faster, so we're expecting to get a bigger number than 8, or we've done something wrong. So always look for clues in the question to make sure that you're staying on the right track. So the rise is 100 meters. And the run is 10 minutes. And 100 divided by 10 is actually 10. And if we compare them, we did get 10 meters per minute is faster than 8 meters per minute. And they want to know how much faster diver B is diving than diver A. So to figure out how much faster, a lot of you could just do it in your head. It's 2 meters faster, but if they were harder numbers, you would subtract to find the difference. So diver B is diving faster by 2 meters per minute. So it would be B. Okay. Example 3. Karina wants to rent a snowmobile for a day and considers 2 rental companies. The relationship between the total cost of renting from Trails R Us and the number of kilometers traveled is represented by the graph below. So this graph is Trails R Us here. We can see that the initial value is at 30. If we wanted to, we could figure out the rate of change, but we don't know if we have to yet. So we're going to keep reading. And we can see that the scales on the horizontal scale, it's the number of kilometers you travel. And on the vertical scale, it's the total cost. So these are the costs over this many kilometers for renting a snowmobile with Trails R Us. So then it says Off-Roads charges a flat rate of $90 for a day with unlimited kilometers. So that means that no matter how many kilometers you go, it's always going to cost you $90. So if you rent the snowmobile and decide, I'm just going to stay in the cabin all day, you still have to pay $90, which is up here. If you use it for 20 kilometers, you have to pay $90. Doesn't matter how many you do, it's always going to cost you $90 for an unlimited kilometers. So it's going to be one of that horizontal lines where the initial value is 90. It's always 90. The value is always 90. So the rate of change is 0 because we're not changing at all. We're always staying at 90. So this one I just drew represents the Off-Roads company. So we've got 2 lines drawn on our same grid now. And it says, at how many kilometers is the total cost the same? For both rental companies, show your work. So you can see that this line and this line only have 1 point in common, and that's right there. So that is where both Trails R Us and Off-Roads charge $90. Okay, and it wants to know how many kilometers that is. So at 80 kilometers, Trails R Us charges $90. And at 80 kilometers, Off-Roads also charges $90 because it always charges $90. So at how many kilometers is the total cost the same? So when you see you're comparing lines and they want to know where the lines are the same, it's always at what we call the point of intersection. This is called the point of intersection. So when it wants to know where 2 lines are the same, you're looking for the point of intersection, okay? And then you have to answer the question they asked. So at how many kilometers is the total cost the same for both companies? Therefore, so the 3 dots, at 80 kilometers, both companies charge the same amount. Okay. At 80 kilometers, both companies charge the same amount. All right. I think we'll do one more example now. So far, so good. So Jillian has 2 bank accounts After speaking with her financial advisor, she's decided to start a savings account by putting $100 per week into that account. So Jillian has 2 bank accounts. After speaking with her financial advisor, she decided to start a savings account by putting $100 per week into that account. Jillian also has a checking account she uses for her college expenses. It's already shown on the graph. So this one here is her checking account. Checking. So the question is, at what number of weeks will Jillian's savings account and checking account both have the same amount of money in them? Okay, so it's asking about the point of intersection, but there's only one line on our graph so far. So we have to draw the other line that's going to represent her savings account. So when we're doing that, there's a couple of things to keep in mind when you're creating the line, okay? Because you have to create your own table of values. So you're going to take a lot of clues from what's given in the question. For instance, we know our horizontal axis is going to be what's in our first column. So we're going to put N, which stands for number of weeks, in the first column of our table. And then we know the vertical axis always represents what goes in the second column of our table. So we know that amount in the account is going to be what goes in the second column of our table. Okay? And then we're going to take clues about what numbers to put in our table from the numbers down here. Okay? So we can see we go by 4s here. Okay, so we're going to start with 0. So it says, after speaking with her financial advisor, she's decided to start a savings account by putting $100 per week into that account. So on week 0, there's no money in the account. So we can plot that point. That's easy. But instead of putting 1 here, I'm going to go with my graph and put 4 here. Okay, so this grid is kind of giving me points to put into my first column. So fortunately, $100 per week is kind of an easy thing to do. So if I put $100 a week in for 4 weeks, I'd have $400 in my account. So then, and then I can see this axis is going up 400, 800, 1200. So I know I would have a point right there at 400. So this represents 4 and 400. And then at 8 weeks, if I'm putting $100 a week into the account, I'd have $800 in my account. And then if I'm looking at my bottom scale here, if I have after 12 weeks, I'm going to have $1,200 in my account. And we're already seeing this staircase pattern happening: over 1, up 1, over 1, up 1, over 1, up 1. So we know that that trend's going to continue because we have a linear relationship. And you can see we've already found that point of intersection. So now we can draw the line in that represents her savings account. So now we've drawn both lines on the graph. One was given to us, one we had to make our own table, take clues from the axes to help us make the table and help us choose the correct numbers for N, and then use the $100 per week to figure out what belongs in our A column. So now we can finally answer the question. So here's our point of intersection right here. So at what number of weeks will Jillian's savings account and her checking account both have the same amount of money in them? So we can read down So at 20 weeks, both accounts have $2,000 in them. Okay. So they just want to know the number of weeks. So that's all we have to say. So at 20 weeks, both accounts have the same amount of money in them. Okay, I'm just going to look through the practice and decide which questions I want you to do while you're finishing copying that out. I'll write them down here. So I think I'm going to have you start with question 4. And then do question 5. Question 7. Question 9 and question 10. So that's 5 of the questions. They're not in the order 1, 2, 3, 4, 5. So make sure you write these out, grade 9s and tutors. They're ones similar to ones we've kind of talked about already. So questions 4, 5, 7, 9, and 10, please. Working on till 10:30, 4, 5, 7, 9, and 10. And then we will reconvene. Okay, so I'm going to exit out of here. Everyone still hear me?
Yep, you're good.
Yep.
Okay, good.